Good afternoon, everyone. Welcome to the inaugural Minna Distinguished Lecture in Engineering Ethics. I'm Shankar Shastri, Dean of the College of Engineering, and we are excited to be hosting today's program and our very special Minna lecturer, Leah Jamieson, the John A. Edwardson Dean of Engineering, and the Ransburg Distinguished Professor of Electrical and Computer Engineering at Purdue University. I'd first like to thank our student sponsors who are helping with today's event. They are a new group called BEAM, Berkeley Engineers and Mentors. And you'll see some of them here. So thank you, BEAM. Today's event exemplifies Warren and Marjorie Minna's commitment to maintaining ethics throughout the teaching curriculum. They established the Minna Endowment for Engineering Ethics and Professional and Social Responsibility, which supports the College of Engineering in its mission to educate its students on the principles and foundations of ethical responsibility. We address this by teaching the students foundational ethics to guide their professional activity. This is doing the right thing for the right reasons. One additional feature of this program is that the way we are executing on the program is to select 5 to 6 Minna faculty fellows each year. And then we spend a couple of weeks working with them on developing modules that they integrate into their courses. And then we sort of track what they are doing in the years that follow. So the general plan is that every course will have an element of ethics in it. And this is a somewhat different approach. Thanks to Warren and Marjorie, we've been able to sort of have this teaching the teachers methodology for bringing ethics modules. And the faculty director of the program, Professor An, is nuclear engineering, is here in the program, and he's supported by Fiona Doyle, who's my partner in crime, and there she is. In pulling together this program, we have a active competition. I think it just began this year for selecting the Minna Fellows for the year. And, it's been really a wonderful program. We are now in the 3rd year of the program. So, in addition, of course, we will teach our students both the skills of report writing, technical communication, public speaking, and public service. I'm delighted to welcome the Minna's extended family with us today, including Bill and Sandra Minner. Actually, I'd love to recognize you, Bill and Sandra Minner. Laura Turner and Pam Stellmacher. And Bill and Sandra's daughter, Mara, is an undergraduate in civil and environmental engineering in Berkeley here today. So there's 3 generations of Minnas at Cal here today. So thank you very much for your support of Cal. Warren and Marge, I'd like to present you with a memento to commemorate this inaugural event. Will you please join me on stage?
Well, I could just say what I said back in the round table. The reason I'm here is because of a professor that's departed now. He died, but his name was Wiskasill, the Clement T. Wiskasill, and he was one of the probably the earliest teacher of ethics for Berkeley. I'm not sure, but that's my guess. And I would suggest you add his name under the name of this particular chair and say, quote, dedicated to Professor Clement T. Wiskasill, 1989 to 1952. And then I have copies of his history. It's on the internet. Marge got them off, but if you can't find it or whatever, you can get with me and I'll see that you get one. And thank you so much for inviting me here, and I've enjoyed this thing very much. So.
We'll be glad to add the recognition, so we'll follow up on that. Now it's my privilege to welcome our speaker today, Leah Jamieson. She is the Edwardson Dean of Engineering and Ransburg Distinguished Professor of Electrical and Computer Engineering at Purdue. She's a member of the National Academy of Engineering and served as the president of the IEEE, the Institute of Electrical and Electronic Engineers, in 2007. She's been on the faculty at Purdue since 1976, and her research interests include speech analysis and recognition. She has founded the Engineering Projects and Community Service Program, EPICS, which is a multi-university engineering design program that operates in a service learning context. She'll tell you a lot more about her award-winning work with this terrific program. Please give a warm welcome to Leah Jamieson.
Thank you, Shankar. And I want to extend my thanks also to the Minners, to Warren and Marge, for endowing this program that emphasizes engineering ethics, social responsibility in engineering. It is an incredibly important topic, and I'm truly honored to be the inaugural lecturer and to be a part of this program this year. So thank you from me as well. I'm going to talk about societal contexts and engineering, broadly societal context and engineering, but also then zeroing in on this notion of engineering and society as we think about engineering education. I will talk with you about the EPICS program and then use that as a springboard to talk about ethics as a part of the learning experiences of our students, and then step a fair ways back to just say a few words about a broad view of engineering education and what it is we are really trying to do as educators. And so let me start. I think actually the simplest statement is that we don't need to talk about the societal context for engineering, or we at least shouldn't need to talk about it. If you look at, this is a tiny sampling of pictures that anyone could pull together that say that engineering has been fundamental to enhancing society, improving quality of life, changing the way people live, work, operate, ever since, for as long as we have recordings of towers and bridges and buildings and roads, engineering and society are in fact intimately connected. This was driven home at the end of the last century when the National Academy of Engineering compiled an assessment of the 20 greatest engineering achievements of the 20th century and challenged people to think about the world that existed without electrification, the automobile, the airplane, safe, abundant water. And some of these we take for granted. Some we take for granted where we live, but perhaps are not taken for granted in other parts of the world. But it's a remarkable century of change with engineering at the core of it. And then as its next act, the National Academy challenged all of us to think about what those challenges that we would address would be in the first half of the 21st century. Those areas where engineering would have the greatest impact on human lives through energy, sustainability, healthcare, security, but also the joy of living through the generation of knowledge, the tools of discovery, the ability for people to learn in personalized ways. And so as a premise, why do we care about engineering and society? Because it's there, it's in front of us. And there are a lot of definitions for engineering. One fairly standard one talks about practical application, commerce and industry, and that's really familiar. Design under constraint, which is a fairly technical one, but then goes on to say scientific and technical knowledge to solve human problems. I will say that my personal favorite, we were talking before this started, Neil Armstrong was an alum of Purdue University, and he gave a stunning speech about engineering and said that engineering is about what can be. And simply that encapsulation is that engineers imagine a future that's different from where we are, and it's about solving human problems. There's both a long history, but also a recent history for the context to to connect engineering and society through our educational processes. And I would start with the Morrill Act, during the Civil War, the creation of the land-grant institutions that said that there should be practical education accessible to the public in agriculture and the mechanic arts. In other words, those things that would affect people's daily lives. But also a lot more recent drivers. Probably the least fond among academics, the fact that ABET, in fact, has renewed their interest in broader characterizations of what should comprise an engineering education, which includes professional and ethical responsibility, the broad education needed to understand the impact of engineering solutions in a global societal context, a knowledge of contemporary issues. The Kellogg Commission, the Association of Public and Land-Grant Universities, report on the scholarship of engagement. So not what do universities do purely in research and education, but how are universities in fact connected to our communities. And then the National Academy weighing in with the Engineer of 2020 and again the grand challenges. One of the formal instantiations of connecting engineering and community through learning is through service learning. And it's a term that has a fair number of definitions, but fairly common components. Connect community service with academic learning outcomes in the discipline, built upon a principle of reciprocity, that by connecting university and community, that both are in fact benefiting, and that reciprocity is essential to this partnership. So if it's a given that engineering and society are connected, and that we as educators, in fact, are helping our students make that connection, what's the problem? So this is a snapshot. This is a report that was published by the American Society for Engineering Education 2 years ago now. And one of the components of the report was a survey conducted in 2009, 110 faculty committees from 74 different departments across the US, exploring a whole bunch of aspects of what do you practice, what do you value, what is the state of the art and the practice of engineering education. 61% of the committee respondents said that service learning is not important or only somewhat important, and is not practiced or practiced only somewhat in their department. And so if these are so important and so connected, why is it not part of who we are? And there's a long history of trends and patterns in engineering education that suggest that we had 50 to 60 to maybe 70 years of engineering focusing on engineering science, which wasn't about the application of engineering. That happened after you graduated, and the pendulum is swinging back to say, no, actually engineering education is squarely rooted in both practice and in engineering science. A total aside, and I'm just doing this because it's something I think is worth noting, and this is about 10-year-old data at this point, but there hasn't been a newer poll. Other reasons why it matters. The public does not see the connection. This was a Harris poll, US perceptions, public perceptions of engineering, and the people sampled were asked, do engineers create economic growth? Do scientists create economic growth? Percents that agree. And what you see for engineers is that, in fact, a fair amount of the public thinks that we do create economic growth, that we would make a strong leader. And then we get into things that have more to do with community and well-being of society. And the numbers go downhill pretty quickly. 37% think that engineers care about the community. 28% thought that we were sensitive to societal concerns. 22% thought we improved the quality of life. 17% thought we protected the environment. 14% thought we saved lives. So we would immediately say that, of course, engineering is connected to society. There's a whole big populace out there that actually doesn't see that. And so education, as with most things, is a pretty good place to start. And so I'm going to talk about EPIC. Stands for Engineering Projects and Community Service. This is a program that was launched at Purdue in 1995. I was one of the co-founders along with Ed Coyle and Hank Dietz. Now there are EPICS programs at over 20 universities and 80 high schools and continuing to grow. So to back up, motivation for this. Early 90s, industry was being actually quite vocal about things that they thought the people they were hiring didn't know, that they were seeing engineers who could solve technical problems like whizzes, but then knew nothing about working on teams, had very weak communication skills, would not know a customer if they tripped over one in the hallway, didn't understand project management, no experience with leadership, nothing formal about ethics, societal context, professionalism, and industry was becoming pretty vocal and saying, you guys should do a better job. At the same time, this is the era when the notion of digital divide was getting a fair amount of prominence. And one of the places where the digital divide was at risk of playing out most dramatically was, in fact, with community organizations, not-for-profits, K-12 schools, human services agencies. Everything that we did was based on technology, and it was typically too expensive for community organizations to have access to that technology. So inability to improve services, enhance their service, create new capabilities. And so EPICS grew out of trying to bring these two groups together, with the additional observation that engineering will in fact be central to addressing global grand challenges, and that universities will be engaged in their communities, both locally and around the world. EPICS is a series of courses, but to make this real, let me just quickly describe a few projects to give you a sense of what we're talking about. EPICS projects have fallen, roughly categorized into 4 areas. First, in access and abilities. And so what's shown on the left is a dollhouse that's been constructed by a group of students from a number of different disciplines, working with an agency that provided services for families of children with disabilities, and in particular cerebral palsy. The clinicians talking about these children would note that because they have very limited motor skills, they don't explore the world in the same way that normally abled 2-year-olds or 3-year-olds would. And so they don't get a sense of sensory stimulation. They can't vary the sensory stimulation because of the limitations in their motor skills. They don't get a chance to explore cause and effect. I do something and it moves, it makes a noise, something happens. And finally, that in playing with other children, they are never, ever in control of the play. And so the challenge to the team of students was to say, build something that will give them multisensory experiences, let them experiment with cause and effect, and every once in a while be in control of the play. And the EPIC students designed a series of doll houses. This one is a bathroom module. The subfloor or the basement is basically an electronics shop. Microcontrollers, controllers, motors, gears, everything to make it work. The toilet seat goes up and down with the child hitting a very large format touchpad. And it's only the child with the touchpad who can make the rubber duck go around the bathtub and sing. And so it's an access and abilities project. Human services, a number of projects. The one shown here is a project that is continuing in partnership with Habitat for Humanity. Students designing earthquake and tsunami resistant low-cost housing designs for use in Haiti. A lot of education and outreach projects. This example, it's a model Mars rover that has been deployed in a local children's museum. And finally, again with Habitat for Humanity, an environmental project, an energy efficient, low-cost house design in southern Indiana. Habitat's purpose in engaging students to work on this was to demonstrate that energy efficiency does not have to be expensive, that in fact you can build this into affordable housing. So these are the kinds of projects that students are tackling. It is a track of courses. They're design courses built around long-term partnerships in the community. The students earn academic credit. The projects are engineering-centered, but they are also multidisciplinary. It's hard to design a good dollhouse for young kids if you don't have somebody on your team who knows something about young kids, as an example. And they're vertically integrated. So the best analogy is it's a sports team. There are freshmen, sophomores, juniors, and seniors on the team. They have different roles because they have different backgrounds and know different amounts of engineering. But the projects go on. The seniors graduate, the team continues, recruits new members. And so you can create projects of significant complexity that actually span semester boundaries. So there's an emphasis on experiencing engineering, but also a dual emphasis on connecting with community. It's essentially a design firm. The teams are fairly large, and this is partly to support the vertical integration so that in fact you have enough depth to be able to continue projects across semesters and years. Long-term participation, students earn academic credit up to 4 years. Low number of credits per semester because the emphasis is on participating over a greater time rather than immersing yourself in a project for one semester. And although it started in electrical and computer engineering, has evolved to be truly multidisciplinary. This past academic year, there were students from 70 different majors at Purdue participating on different teams. And it's about design, start to finish, define design, build, test, deploy, support. There's an educational context that talks about multi-level learning, experiential education, active learning, problem-based learning, inquiry-guided learning. It is certainly in the realm of design education. And on the service learning side, tenets about engagement and community tied to specific academic learning outcomes. So it's not just doing community service. There are learning outcomes that students are documenting, for example, to fulfill outcomes for accreditation. Reciprocity is central, and some of this is language, talking with students every opportunity that you are not doing something for the community. You are just doing something with the community, because although they are benefiting from the project that you're working on, you are benefiting in enormous ways from the learning that you're gaining by this opportunity to work on a real project that is grounded in societal needs. And finally, a reflection component. Think about what you're doing, both the technical side, but also what are you learning about these professional skills, ethics. I will tell you that in 1995, when we started this and had to submit a experimental course outline for what this was, the word reflection appeared nowhere in that outline. To present an engineering faculty something that said, you're going to have these exercises and the students will do this, and then in weeks 3, 5, 7, and 9, there'll be reflection activities. At that time, there would have been a lot of laughing and jokes about mirrors, and it was not a part of the engineering lexicon to talk about engineering students reflecting and thinking about what they were doing. One of the concepts really at the heart is that it's human-centered design, which also was actually not such a big topic in 1995, but it is maybe an exemplar for human-centered design. What are human needs, and then what is the cycle around which you try to meet those? There's a service learning context. I will tell you that when we started this as 3 electrical and computer engineering faculty, we knew none of the service learning context. We went to a conference because we had funding. We went to a conference that was a gathering of people in service learning, and 2 things happened. One, we were the only group that used PowerPoint to present, or slides to present. Everybody else just stood up and talked, so we apparently came from a different culture. And the second is we actually got used to people saying, "You're an engineer? Why are you here?" And it was a very different world. Since then, an edited book by Edmund Sang, who really was one of the pioneers in engineering service learning, and then a book more recently by my colleague Bill Oakes and Mary Beth Lima to help provide some framework for this, for education. Why are the projects long-term? Why does that matter? Because apart from the fact that it's community-based projects, these are projects that extend multiple semesters, sometimes multiple years, and that grew out of the curricular structure that actually enables some things that are unusual in academia. The projects are delivered. You know, somebody created this project, it grew out of a need, and you didn't finish it by the last week of the semester. Maybe it wasn't realistic to finish it. You had to have created a project map, a timeline, and you will be graded against that. The hope is that you will also, over time, get better at developing your timelines. But at the end of the day, what really matters is that whoever your community partner is, you will deliver a working, reliable, responsive project to them. And so being able to work across boundaries enables that. You can keep improving it. You can incorporate new ideas, which are actually pretty reflective of what happens in real-world projects. There's time for students to learn disciplinary depth and multidisciplinary breadth. If you don't know something but your project needs it, you can learn it. That's getting easier because now you can find a MOOC about it somewhere and learn it on your own. And so that part's actually getting easier with time. But there's also time to gain some of the things that are not typically taught in a structured, didactic form. You don't learn social responsibility in a 5-week module where somebody explains to you what social responsibility is. It comes from living the project, understanding the people whose lives you may be affecting with what you're doing. Self-awareness and team awareness. Teams evolve over time. And how you function on a team is something that changes and you develop over time. And professional skills, including things like communication. Again, don't happen overnight. They develop over time. And opportunities for long-term mentoring. And much of the mentoring that goes on in EPICS is actually from the upper class students to the newer students in the program. And so passing on that experience. The ultimate, and I would say the Holy Grail in this, which I think is, all of us are challenging ourselves to do, is to say, can you create a meaningful interaction between what students are learning in their disciplinary courses and what they actually do in design courses, so that there's not a disconnect between learning what a Fourier transform is and building a microphone array to try to approve a hearing aid and realizing that, oh, you mean there's an analytical way of thinking about that? Because students tend to partition the knowledge. This is what I do in my lab class. This is what I do in my theory class. This is an opportunity, because you're doing it over time, in a virtuous cycle to make the knowledge go back and forth. It's hard to measure and it's hard to achieve, but I think it's one of the opportunities that does get created through vertical projects. Second question, why community-based projects? So when we were starting EPICS, we thought that vertical structures were great, and then we ran into what we felt like a brick wall. So where are the projects that are so interesting that students are going to want to work on them for multiple years? And in conversations with industry, they actually weren't particularly interested in having our students spend a few years working on a project. And so this idea that the projects in the community, because they're solving real problems, might in fact be able to capture students' imaginations in a way that you would want to come back and take this course over and over and over again, bringing something new to it every semester that you register. There's a lot of learning, start to finish design, not only how to solve problems, but how to define problems, because we talk about ourselves as problem solvers, but really the best engineers are also question askers. What problem should I be solving? Specifications, version control, testing. Also design for X. Design for whatever the project is, be it reliability, usability, aesthetics, manufacturability, to understand that. We had a team that wanted to deliver a project written under Unix for a social services agency who had no tech support in-house at all. It wasn't going to run for very long because they didn't have a resident Linux expert to keep the project running. And so just exploring that whole space of how you match customer needs with not only your technical skills, but what's going to match the needs of the customer. But also the philosophical things. The student is a citizen. That you are an engineer, you can use your engineering skills to make a difference. And also take that up a level. The university is citizen, that the university can also contribute to the community. A lot of educational outcomes, it is mapped to accreditation outcomes, evaluated right and left, portfolios and rubrics for doing this. This is a self-assessment by students that was accumulated over about 15 semesters of data, so a fraction of the time that EPICS has been running, asking students, what was the impact of EPICS on your ability to work on a team, communication skills, and what's shown are the percent of the students who gave this a positive rating, an A or a B rating, and at the top of the list every semester without exception is ability to work on a team. And then it moves down to a lot of things that I'm going to come back to, a couple. I'm going to come back to the community and the ethical issues. We were always frustrated. What do you mean only 71% of your technical skills? You're actually building really sophisticated things. So we actually ran some focus groups with students to say, could we delve into this technical skills? The simple explanation that we heard over and over is, well, nobody taught us anything. Which was true. Very little technical teaching in the program. Sometimes there'd be some skills sessions where TAs would dig into something. We have a group of students who need to know Java. They're not up to speed. We're going to spend 5 weeks crash course on Java. Somebody taught them something. But a lot of the learning played into the lifelong learning and how do you do this. And so it wasn't that they didn't learn any technical skills. It was that nobody had taught them the technical skills. And that's also for students to think about that difference and for us to think about that difference. Before I come back to those specific components, let me just mention 3 more examples because the heart of this is in what is happening in these projects, both on the technical side, but on the teamwork, the communication, the learning, the community impact side. Also in accessibility is recently a team that developed an iPad app called Speak All. And it's for children with autism who can use icons, images on the iPad screen to then construct sentences that it will read out loud so that they get a translation of something to them that's very easy, which is pointing and looking at images, but also hearing the translation of that into language to be able to make clear what it is they want, but also to contribute some to continued efforts to learn language. The human services, the lower right picture, was taken in Cape Town, and this is a partnership with IEEE. Students at University of Cape Town working with a local high school in Cape Town, also working with some professional engineers from the community. And in this case, what they kept telling me is they built a geyser for an orphanage. And I'm like, okay. I'm not sure why an orphanage needs a geyser, but I had the just incredible fortune of then being taken to see this. It's a hot water heater. An orphanage for children who were orphans because of AIDS. In the townships outside Cape Town, electricity was too expensive for the orphanage to be able to afford to have hot water. And so a group of students, university students, but then also working with the high school students, and incredible entrepreneurship among these students to connect with companies in the community to make donations and work with them to acquire and then custom design aspects of a hot water heater system, adjusting the system so that the solar panels on the roof are effective but not visible, so they wouldn't be stolen, developing a security system, because this is certainly a one-of-a-kind thing in the township, and unbelievable learning for both groups of students, and hot water for kids living in the orphanage. And finally, on the left, this is an island outside Auckland. It is isolated, so everything they do, they have to ship onto the island or ship off the island. And so they have been doing a series of environmental projects aimed at what can you recycle so that you don't have to import and export as much stuff from the island. And in this case, 2 projects. One, turning waste glass into sand for use in construction materials. And the second, there's a fairly large tourism base, waste cooking oil converted to biodiesel as an alternative fuel. And so reducing the amount of goods and material that has to be exchanged from the mainland to the island. So EPICS was started, as I said, in 1995. Started with 40 students from electrical and computer engineering. They served on 5 teams. The dean, then dean, who was a good friend, and is still a good friend, reminded me on every occasion that we had better not be putting their ABET accreditation at risk by having such a different design course for some of the students. Rough estimate, talking with my colleagues, our experiences at service learning conferences, scouring the literature, is that at that time there were maybe between 3 and 5 engineering-centered service learning programs in the United States. This year, the Purdue program has 31 teams, consistently well over 400 students every semester. They come from 70 majors. It's coming up close to 9,000 students to date. There have been over 300 projects deployed in the community. Purdue just for its first time adopted a university-wide core curriculum. This is an elective in the core curriculum, fulfilling a technology and society requirement. And in the last ABET visit, and for the one that we hope will happen, well, we don't hope it will happen, we know it's happening in the fall, but we hope that the reaction will be the same, that it was in fact noted by ABET as one of the highlights of their visit, and something that was in fact communicating engineering in ways that were valuable. And globally, over 20 universities and over 80 pre-university sites, and this is with a partnership with IEEE. Most of the university sites with IEEE globally, Africa and India in particular. So this talks about community engineering. Where does ethics fit into this? And we've had some great discussions earlier this afternoon about what kinds of ethical issues do engineering students face, do engineering faculty face, and how do we create conversations about ethics with our students that are in fact going to be meaningful? And so if I will point to in terms of this, these are positive responses, but there's obviously room for improvement. These are what students were saying, their impact on their awareness of ethical issues. So we have, since the beginning, on a continued journey to understand effective ways to integrate ethical, both awareness and practice through this service learning experience. Curriculum materials and assessment, not only for EPICS, but in general for multidisciplinary team-based engineering design courses. At Purdue, employing our staff and faculty, but also PhD students from sociology and philosophy as some of the resident experts on this. A collaboration, which is spelled in a very odd way, with 3 other universities, in the Illinois Institute of Technology's IPRO program, Michigan Tech's Enterprise program, and Lehigh's Product Development program, funded at Purdue through an internal seed grant, but then the 4 universities through a National Science Foundation TWOS grant, transforming undergraduate education in science. And this is a work in progress, and I think it will always be a work in progress. And for us, the focus is because of the service learning context, because these students are designing and then building things that will, in fact, if they're done well, will be used, it's not only on awareness of ethics, it's actually practice of ethics, because people's lives are touching what the students have built. And so I'm going to quickly just run through some of what this looks like. And our starting point was with some student reflections. 4 questions. What are the ethical issues or potential issues you encountered this semester in your work with ethics? So you're on a team, you're working on something. What ethical issues have you encountered? What were possible solutions? Which solutions did you choose, and why did you choose those solutions instead of the others? In talking about the Minner program and the Minner Fellows, this question not only of making the right choices, but making the right choices for the right reasons. So why did you do those things? And what would have happened if you didn't address these? For over a course of a couple of semesters, had the students doing semester end reflections. And in the context of these 4 questions, the most common problem that grew out of this was actually identifying the ethical issues. It wasn't what did you do, how did you do it. It was like just looking at a situation and saying, there is an ethical issue in that. And this was something that the students struggled with enormously. Also noted, most of it, at least in terms of the projects, pretty narrowly focused on safety and professional obligations. Not broader issues of social justice. It's just, is it safe? What does my profession say I should be doing? But also difficulty articulating, when they could identify an issue, difficulty in articulating it, this notion of an ethical language, which simply was not part of their education. And so have continued to build on that, with a focus on moral decision making. How do you identify ethical issues? Awareness of multiple frameworks, that there are in fact some formalism, some ways to think about ethical issues, and that there are levels of moral reasonings which get into this question of why. And so structured around 4 frameworks: learning objectives, foundational models, curricular components, and assessment. The objectives, this is a long list, but it really hits on those. Can you identify issues? Can you identify stakeholders? Can you place them in a framework? And note that there are different ways of placing these in frameworks. And then, can you argue for a course of action? There are a lot of foundational models, the 2 that we have found useful, Kohlberg's, which basically says that there are different levels of ethical reasoning. There is the baseline called pre-conventional, which you do things out of personal interest or because you're supposed to obey or you'll be punished. You move up the scale and level of thinking that has to do with maintaining social norms, which could also be professional norms for engineering students. But the post-conventional is where the ethicists will say you would really like society and people in society to be, is to be able to frame this in a context also that thinks about the greater good, and with the individual maturity to think about the ethical principles in a way that you make a decision that is consistent with your own well-grounded ethical standards. And then, again, building on notions of sensitivity, judgment, motivation, and action. The curriculum is obviously a place in a course where a lot of the thinking and work has been done. We have introductory lecture for all students focused on ethics, but we've also now woven this into our design lectures. And so there's a continuous thread. This is a design course. And so there are continually lectures about design, which connect ethics in and where does that play into the design process, tied to human-centered design, continuing to build a library effectively of short cases, some of them real or generated or inspired by anonymized past projects, because this is an area where making it real speaks in ways that hypothetical situations appear not to. Small group, what we call skills sections, around social context, around ethics, and then within each of the teams that is working on a particular project with a community organization, an ongoing thread of case study discussions in the context of that team's projects, both currently what they're doing, but also looking back a ways for hindsight to say, okay, you delivered that project. How's it going? Are there things now that you're looking at that maybe you framed as technical decisions, but with a little more distance, there were some ethical aspects? So practice and discussion and just opportunities to connect the engineering with a sense of ethical reasoning. Also absolutely critical in this TA training, because our teaching assistants are, for the most part, coming to this without much formal education either. And on good days, I would also say faculty training. Sometimes that goes better than others. This is a snapshot of a case study, just to give you a sense of what this looks like. So it's a team project. They're designing a database for local school districts. The principal has provided the specifications. Halfway through the semester, they meet with the superintendent from the school district, who gives them a different vision, including some information that contradicts what the principal said. At the end of the project, and they just keep going, at the end of the project, they deliver it. The IT technician for the school district says, I can't install this. It was created in the wrong technology, and then tells the students, you need to do this, this, and this, and then it'll work. But it changes the functionality from what either the principal or the superintendent said. This is a realized, this happens, real customers, you know, all sorts of things happen. And so what do students do? How do they think about this? How does somebody in industry think about this? How are they going to think about this when they're working? And then the work with them is to pose a set of alternatives of what you would do and why you would do it, and to get them to talk about which one of these would you do as an individual or as a team, and why would you do it that way? And then to connect that to the models, the Kohlberg and the Rust models, the levels of thinking. And if they get it to the first one, you build the principles because he's been the regular contact and he might not be happy if you do something else. This is kind of the punishment level, that, you know, well, something bad's going to happen if I don't follow the rules. If over time, if the students get to the last one that says, you listen to everyone, because they're all stakeholders, and maybe your role in this is to be the facilitator of the communication that needs to happen to actually come up with a solution so that they will, in fact, have a system that's useful. But that's a higher level thinking, and it takes a while to get there and to see that. And then the last part, I'll just note, there is an assessment. How do we know if our students are making progress? There are standard instruments out there. There's one from Minnesota. There are a couple from Georgia Tech. As part of the NSF-funded project, also developing some things specifically zoomed in on engineering, both for individuals and for teams, and a pretty rich set of mechanisms, pre-post surveys, reflections, skill sessions where they're writing assignments and discussions, and observation in the classroom. So the connections between service learning and engineering, I mean, we started with saying that engineering and society are obviously connected. Nobody's going to question that except for the general public that doesn't quite see the connection. But the connection with learning and engineering education and community and society has not been as clear. I would say that based on the experiences we've had, it is an incredibly rich learning environment that also we think is providing opportunities for our students to learn some things that are traditionally very, very difficult to teach in a traditional classroom via lectures. The notion of experiencing and exploring would make a strong case that there is something, even though our students are not, for the most part, going to go out and work in the public sector. that the lessons learned for this, in fact, can enrich everything they do in the future. Part of the end of semester evaluations, there's a bubble thing where you say how much you've learned in various things, but there's also a comment part, and I think all of us who've worked with EPICS, each of us has our favorite quote that comes out of the student assessments. And so I'm just going to close with showing you two of them. One of them I think is one of the favorite quotes of my colleague, Bill Oakes, who is now the director of EPICS, that no longer is engineering just a bunch of equations. Now I see it as a means to help mankind. And my all-time favorite, because I never thought that in an engineering course I would see a course student evaluation that said, "It opened my heart." And so I thank you.
Should we take a few questions from the audience?
Hi, my name is Carly. I'm a second-year civil engineering major. My question is, how does the EPICS program pick the projects that get worked on? Does the community approach EPICS and say, we need this done, or
Sure.
do the students go into the community and pick something?
For the most part, it's done through the EPICS program. When we started, we had the good fortune of Ed Coyle, who was my colleague, lived next to the director of United Way for our county. And so when we started thinking this might be something we can do, he simply went and asked, could we come talk to the directors of the United Way agencies, and could we present to them this idea that our students could work with them to do things? And so we worked through United Way. We worked with school districts because that was a fairly easy thing. We all had kids in school, and so we thought we'd do the school districts fairly well. Over time, but also even in the first semester, some students heard about it and they came and say, well, I've been volunteering at an agency that works with kids with disabilities. Couldn't we do a project with them? So it's come from multiple, over time, more and more, the agencies come to us because we're known in the community. One of the things that's been critical, I would say, for sustaining this is the fact that we don't have to go out and generate a whole new set of projects every semester, especially as the program has grown. So that notion of stable partnerships, one of the measures for us of success is that if we've been working with an agency and deliver a project that's honest to goodness, this is it, it's working, it's done, instead of going away, they come back and say, well, I've got another project, because that for us is probably the real proof that they feel there's value in it.
Good afternoon. My name is Oscar Dubon. I'm a professor in material science and engineering, and I'm also the Associate Dean for Equity and Inclusion in the College of Engineering. And I am really excited about the topic of service learning. We are actually in the process of designing an American cultures course for our engineering students that will integrate service learning. So I'm really thrilled to hear about the wonderful activities going on. I have a question about the industrial response. So now you have a whole generation of students, many students who are going out into industry and have this experience and certainly bring that to the table when they are exercising, where they're practicing engineering. So have you received any feedback? Has that made a difference?
Yeah, it has. One of my other favorite quotes that I didn't have, and it's been a while since I read it verbatim, so I'm going to have trouble reconstructing it, but basically was from a company that hires a lot of our students saying, I will hire an EPIC student over all other students who are interviewing because they understand what it is to work on real projects. The response, our students tell us that it is invaluable as interviews, that when they start talking about their EPICS experience, when they're interviewing for a company, they often never get to anything else and they get so many questions, but then they get jobs, so that seems like it's a good thing. But the industry response has been really strong. And one of the interesting places has been through the partnership with IEEE that's also involving some of the practicing engineers in communities, is that it's making a connection between local companies and the university and the schools, and that dimension of it has also been valuable. And industry support for the program has been one of the key things to sustaining it financially. So industry has been, and since you mentioned diversity and inclusion, and women, lots of data at this point that say that women disproportionately choose to do this as their design experience compared to the base population. Similarly, for underrepresented minorities, it's just the numbers for us are smaller, so they're not as robust. But it has been, it's been a way of, the retention of our first-year women in engineering is significantly higher for the women who do service learning in the first year, and that's.
I'm going to pick on Cara, just giving you a 30 seconds warning.
Okay.
You know, a program that's been popular in the College of Engineering has been sort of the power of technology to lift people out of poverty. And several exemplars of faculty here in this room, but Cara has been working on sort of sending students into the developing world to do safe water and sanitation. And Cara, I was going to ask you sort of what your sense is of the models of service-based learning for those models. I've seen her students in slums in Bombay and floods, you know, working on clean water and sanitation. And so the question is, what lessons should we take from this? And what do you see as the parallels between these programs and these are primarily in the US, right? Or you're all over
Actually,
the world?
all over the world, both university programs and certainly the partnership with IEEE is all over the world.
The floor is yours.
The parallels are obviously tremendous. I was thinking actually throughout the entire presentation about the convenience of working with communities that are local, because it is clearly so much easier to be in close contact with them than when you have to travel. And that gets restricted to the semester breaks and the summer time. But one of the things that really strikes me about the EPICS program is how formalized it's been integrated into the engineering curriculum.
Yeah.
And a lot of the activities we have going on here through our Engineers Without Borders, student organization, through activities at the Blum Center for Developing Economies, are still really, to a large extent, extracurricular, where students have to use really creative mechanisms to integrate them into their formal coursework through doing independent studies or through student-led courses. We have a program here called DCAL that allows students to do that. And as a result, I think that they are challenged to get the level of support that they really would benefit from our faculty. So one of the things I've been wondering is how you, in integrating this more formally into the curriculum, what kind of incentives and mechanisms have you provided to encourage and also recognize the contributions that faculty can make? Because you know what it's like,
Yeah.
how we're always trying to balance a portfolio of so many demands, and recognize this is the kind of mentorship that requires a lot of not just time but really thoughtful input on the part of the faculty. And so I imagine you've tried some different things and might have something to share that would help us understand how you can also give credit for this kind of contribution, because it's not the same as just teaching a regular class.
Yeah, and that's really at the heart of it. And so a lot of benchmarking early on with some of our faculty, especially in mechanical engineering, because in the mid-90s they were ahead of everybody else at Purdue in design courses, to benchmark level of effort for faculty who were involved, not in teaching teams, but in coaching teams or in mentoring teams, coming up with what we hoped was a realistic formula that advising a team is not the same as teaching a traditional 3-credit course, but maybe if you do a team over an entire year, that's about the same amount of effort. And then hours and hours and hours and weeks of negotiations with departments to say, if a faculty member does this, it shouldn't be an overload. It's got to count in their course. And that continues. I will say, we're 18 years into this, and if the budgets get tight or things get tight, it's still, well, I could assign someone to teach one of my courses or to EPICS. Well, that's an obvious choice. And so it's still a discussion that goes on, but it's negotiations with the departments. Getting it approved by some of the programs to fulfill the capstone design requirements for ABET. And this was the source of the comments from my dean, that this had better not be jeopardizing ABET. But that was probably one of the single most important things that happened, is that we had a couple of degree programs, and now increasingly, we just have another one coming online this year, saying this is going to fulfill capstone design because we developed a documenting system that people deemed robust and rigorous enough to say we actually were evaluating the learning outcomes. They were documented in a way that a hardcore ABET evaluator would look at and say, okay, that passes muster. And I think the other part is that, so the three of us who started this didn't come out of the education side of the house. We actually came out of the signal processing, communications, and computer software side of research side of the house. And so I guess I would say we played by the rules. We got grants. We wrote papers. A lot of them were conference papers, but we actually started publishing papers in the reputable education journals. But we also had papers appearing in technical journals. I co-authored a paper on signal processing in community. So kind of playing by the rules of the establishment to convince people that this actually was real, that it wasn't something that we were doing on the side or that anybody else should be doing on the side. And then the other part was, as we were writing grant proposals, negotiating with our department chairs and deans that they would provide some measure of cost share in some form. Even now it's harder because NSF will tell you you're not allowed to do cost share, and so you kind of, but they don't mean that. Their panels still come back and say, well, what are you putting in? But little by little, every time they put in $100,000 to match the $100,000 grant, they had now invested in this. And so it was this sort of, I guess, subversive way of getting the institution and the administration to buy into it and say, oh, we've got a vested interest in having this succeed. And after a while, it just started succeeding. And then they started hearing what the students were saying. And but it was actually establishing by the traditional ground rules. But also, letting a department get by. Okay, if somebody needs to do it for an overload for a year, fine, but you can't do it indefinitely, because if it's an overload forever, you're saying you don't value it, and we don't want faculty here who aren't being valued for what they're doing, and having to actually be pretty hard-nosed about that.
Very good. Thank you very much. So I'd like to. We'd like to thank you, but before you go, we'd like to give you a little gift to remember your day at Berkeley, Leah.
Thank you.
And to be the inaugural Minna lecturer. And here are the folks that...
You want us over here? I got it.
Hold the pose.
The photographer's in control. Thank you.
Thank
you so
No,
much.
thank you. Thanks very much.
Thank you.
Please join us outside in the Garbarini Lounge, just out here to the left, for refreshments. It's a hot day. I think that we have some cool drinks outside here, and a chance to talk to both Dean Jamieson and the Minna family. Thank you for being with us today, and go Bears!